Hi everyone, today we're going to take a look at the first backend services. In one of the first videos I already mentioned that I want to work with .NET Core and gRPC, so I use both of these techniques in the first service, which is the character API, and this character API is responsible for informing other players about each location on the map. So let's take a look at Visual Studio. As you can see, I have these two projects over here, and I have the character API and the authentication API, which is also important. And I didn't intend to share this. Well, let me see the character API, and it's quite a clean surface. It's still a really simple one. It's not fully functional. So let's take a look here. It has a program CS, which is pretty simple, pretty default stuff. And a startup, which might be a bit more complex. You can see I did some stuff with the course, which is important because we're hosting our backend on a different domain than the front end. The front end is hosted at game.hellomoon.nl, while the backend is at api.hellomoon.nl. And the authentication is even at auth.hellomoon.nl. So course need to be implemented correctly. I made one for HTTP calls or regular HTTP calls, the REST calls, and one for gRPC, which has some additional stuff there. I'm not completely into this, but at least those are important. And what it basically tells you is we allow HTTP calls or gRPC calls from any origin, from any method, so a post, a get, an options, or whatsoever, and we allow any header method or any header to be passed to the backend. Now we have authorization with a default policy, and this default policy requires a scope containing a character API. So when you're using OpenID Connect or OAuth, then you will see that there are scopes, and within this scope you can define what the authentication authentication token is allowed to do. So you can have a token that can only fetch your username, for instance, but you can also have a token that can connect to the character API. And you might know these from these access screens or these consent screens when you're trying to log in with Facebook, for instance, or to log in with Google, and it tells you, hey, by allowing this application, you're giving access to, and then it tells you to can view your posts or whatsoever. So that's basically, those are scopes. Now, there's authorization and authentication. I had to look twice. Authentication is telling who you are, and authorization is what you can actually do. I have to say the different. Authentication is whether you have access or not, and authorization is what you can do. So authentication, we're using JWT, and so this is the scheme, and we're fetching the metadata from the authentication server, and we validate the audience false. So we do not validate the audience. And this one here is pretty standard. Also mention the course here, authentication, authorization, and we're using gRPC-web. And in our endpoints, apart from the regular controllers, we also have these map gRPC service, which is the location service. And then we enable gRPC-web again. Now, let's take a look at this location service. This is quite a huge one. And as you can see, it requires authorization and it extends the location base class. And this location base class is generated by Visual Studio for me. And it's based on this proto file. So when you're working with gRPC, then you always have these proto files. And proto files are basically the contract between your services. And based on this contract, you can either create a service or a server, and you can create a client. So these are really useful and making life really easy. As you can see, I'm using Proto 3. I can tell the C# namespace, which is character API. So everything here is in the namespace character API. And we're having a location service, which has an RPC called subscribe. And you have to pass in nothing, basically. You're just subscribing, nothing else. Because we have protected this call with these JWT tokens, we already know what user is connected. So that's basically the information we need, and we don't need any other information. So that's why we have this empty, and yeah, so message is empty. This is just a trick to get things working, because you cannot leave this out. You cannot say I'm just removing it. It requires you to set a message. Now we are returning a stream, so we're not returning one single RPC message, so request response, but we're responding with a stream. And this stream consists of location updates, and these location updates do have a character ID, whether it's online or not, and the XY location. And you can see those 1, 2, 3, 4 mentioned here, and those are required to tell in what order these fields are in the message. So gRPC messages do not contain something like JSON, like a character ID is 1, 2, 3, 4, and online is true, but it just tells you 1, 2, 3, 4, true, and then the X and the Y location. So these numbers are really important to know how to map the values. And so based on this prototype or this proto file, a location base class was generated. We can have a quick look into that. Well, as you can see, this is all auto-generated stuff, and we're not looking into it because it's, well, a lot of code. And it's clearly generated stuff. Now, let me see. We're managing subscriptions over here. We're managing character locations. We're having a list of all characters. And we have a logger. This is also quite nice. And then we have some methods, and those are all private, so let's skip those for now. So they're all private. It's quite some code, but remember, this is just the first dummy implementation, and this is not where we will end with production. So I'm not too concerned about how this is currently set up. It just has to do the job. And this is our subscribe method. As you can see, I have an override async task subscribe. We are having this empty request, and this empty class is empty, as you can see. So there are no properties on there. And we're getting a response stream and also a context. Now the first thing we're doing is we're getting the user from this context, and within this user we're going to search for the name identifier, which is the in OAuth or OpenID Connect, this is the subject or the sub. So, and this is a GUID, so that's nice, and we can parse this GUID, and we have a unique GUID per user, which is quite useful because we can then create a subscription for this user ID and for this response stream. So if a user is logged in at multiple locations, or maybe even just multiple browser tabs, then those are all separate subscriptions. And what you can see, if I go to this add subscription method, you can see that we have a character GUID and a response stream, and it will just add this response stream to the subscription if there already was a subscription. Now, if there wasn't a subscription, we're just creating a new, well, let's call it a record or a new set, and then we're updating also the character location with a generated character location with just a random location somewhere between -2 and 2 on both X and Y. So we know it's in the center of our map. And this update character location just sets the location in the character locations, what is it, dictionary, and there's that. Of course, I missed this one. It also sends a message to all the users. So it says, give me all the subscriptions, select their streams, and then write this message to them. So every connected gRPC stream gets an update that a new user appeared at a certain location, and that is now online. That's maybe important to notice that we really need this online property there, because we also want to inform if a user is offline, so it can be removed from memory, because we're not going to show users that are offline on the map. So that's nice. Then that's the that's the add subscription. Now also a message is created, and let me see. Yeah, of course. So to the newly connected user, we also want to send the location of all the other characters at that moment. So you're just connected, we send a message of your location to the others, but we're missing all the locations of all the other players for you. So that's what happens here. It gets all the character locations and creates an update object, and then it sends it to you in one big message. And of course, later on, we will have to look into optimizing this, because we only want to send updates to the people that are near you. So you only get the characters that are actually fit on your map. So and then this is quite a hack, because what we're doing here is we're just creating a task, delaying to infinity, and wait for a cancellation token. And so basically this await makes sure that our thread is not blocked anymore in C#. So the processing thread is given back to the thread pool, and this process is idling, and while you're still connected, this doesn't do anything. And it's important to do this, because if you wouldn't have this task delay, then it will just finish this method, and since it was an RPC call, it will end this request, and it closes your response stream, and it is done. So basically what you want to do is you want to keep this stream open as long as the visitor has this browser open, or this browser tab. And as soon as this browser tab is closed, or maybe his phone died out of battery, or well, he's driving through a tunnel and is disconnected, that's all fine. Then this cancellation token will be invoked, and this task will end with a task cancelled exception, and at that moment we will remove the subscription for this user, for this user, and specifically this response stream. And we could only give the response stream because we can find the user or the subscription by its response stream, but hey, we do have this user GUID over here, so why shouldn't we just pass that, making our lives a lot easier, because then we have this character API and can get a list of subscriptions and remove this particular one. Now, if there are no subscriptions left anymore, then we will remove its whole record or set, or how you want to call it, and we will update the character location to null. And there's this method again. We already seen this before, and this now this new location is null, so online will be false, and all other visitors will get, or all other browser sessions will get a message that this user is offline and they can remove its location. So this is pretty cool, and let's see. I think this is the most important part. We have a home controller just for debugging purposes. You can see we have this Hello Moon character API title on the page, header 1, and then a table which just renders all the current character locations. And I use this quite a lot while I was debugging and troubleshooting. I run into one serious issue there, that as soon as one user disconnected, so one user closed its tab, then all connections were closed. So so that was quite a pain, and I finally fixed it by using this protocol's HTTP1. By default, it's on, or by default in the version I had of this app settings JSON, it was on HTTP2, which of course is something you'd like, because we're having a gRPC service, and then it's important to do that. But since we're using gRPC-web, it's not needed anymore. And as long as you're running this as a separate service and you're just connecting to this Castro instance, then it would either work with HTTP1 or HTTP2, that's no problem at all. But if you're having traffic in front of it, and traffic is a, an HTTP gateway or an API gateway or whatsoever, well, just make sure that we have this routing available. But this service just closes all the streams for all users if one closes its connection. So it's important to have this at HTTP1. Now, you also see here the authentication API URL, which is on port 5000 if we're running local. When we're deploying, then this URL will be overridden by an environment variable. So there's that. And we're having a Docker file, which is quite clean. I did some hacks here, and I'm not sure if they're really needed anymore. But when I had this setting at HTTP2, it was important to have a certificate over there. So that was the reason I generated a localhost certificate while building. So it's over here. And then this certificate, let me see. Yeah, it's over here. It copies the certificate to the publish folder, and so when we're building the final image, then this certificate is included. And what's nice to notice here is that it uses Buster Slim for the build agent, or the build image, I have to say. But for production, we're using Alpine. So if you've never seen this before, this is basically a two-step image or two-step Docker file where we're using a different image to build our software, and then the image we're using for production or to run the image. So that's the things we see here. We're having a base and we're having a build. And so that's the important part I want to show you about the character API and now the authentication API. The authentication API is based on Identity Server 4. Let me see. I haven't looked at it, I think. This is basically all generated stuff or installed by default. And you still see a lot of default data over here. So we're having a startup file, and I'm not going too much into details about this, but what I did is I changed it to PostgreSQL because we're running in Kubernetes for our production environment, and PostgreSQL or PostgreSQL, not sure about, is run easily within Kubernetes. So that's a good choice, I think. And those are all standard things, nothing special here. We're having in-memory identity resources, in-memory API scopes and clients. And what you can see here is this one's also nice. We are having a developer signing credential, and you don't want to do this in production, but for now I think that's good enough. But we have to change it to a production certificate later on, and that's why this comment is over here, something we still have to do. but it can wait. And yeah, there's that. So let me show you the configuration file, because I did some changes over there. If you're having the standard template version, then you'll see it's a bit longer than the one I have. But I'm having these identity resources, just OpenID and profile, which are standard things in OpenID Connect. And I create an API scope for the character API, which we saw in the character API when we were checking the scope. Then we're having these clients, and you see I do pass in the game URL from the configuration file. So if we're having these app settings, then you'll see the game URL is localhost port 3000. So that's when we're running local, and of course in production, this one is overridden by game.lemon.nl. And it is important to have that because it is needed for the redirect URL. And this is the URL we have in our front end, and I am pretty sure that I'm going to change this one because I saw that the implementation I do have at this moment doesn't work flawless, but well, I'm not sure about what I'm going to do, but for now it does work kind of. So we're having client ID, which is game, and we're having client secret, and well, this is now hard coded, and of course you don't want hard coded secrets in your C# code. So this is something we have to change, or maybe we can even get rid of this secret at all. But again, that's something I have to check because I now used I now used Nextout, which is a nice package, but it's running as serverless as a serverless API, and we therefore need a secret, and it's connecting via OAuth. Well, I think we should just focus on OpenID Connect, and I think you won't need this at all anymore then. So, and then it completely focuses on this redirect URL. But again, that's something I have to figure out. I also disabled this one. We have this allowed grant types, which is a code. You can see here. Code means that we have an authorization code. You can also have client credentials or implicit. So those are the things we can do. We also have device flow, which is used often for televisions or devices without a keyboard. So pretty awesome. Let me close that. And of course the allowed scopes. So this client allows OpenID profile and character API, and this was what I was talking about when I said about when you're having this consent screen, which Facebook apps, for instance, have, or Google apps, or GitHub apps, or whatsoever. I don't want to make advertisements, but one of these social platforms, when you're trying to authenticate with a different app, then it will ask you if for permission to do that. Well, that's a consent screen, and every app has its own client ID. Now we only have one app, which is our game, so I decided to have this hard-coded for now, but of course, when we start allowing other developers to also build apps, then this has to be dynamic and loaded from a database or whatsoever. And then you can also have these dynamic scopes. But for now, it's fine. So let me see. I have some seed data over here. You can see it creates the test users. So Bob and Alice are always created over there. It has some basic views. So when you're checking this login screen, for instance, then it shows you the default users are Alice and Bob and their password. So pretty nice to get things up and running, but of course this is not something you want in a production environment, so we have to get rid of this as soon as possible. Now, this is all nice, and yeah, I'm not gonna look into this any further because I haven't changed anything in here. It's just standard .NET code or identity server template stuff. And again, I've created this stuff over here based on what I did in the character API. One thing that's different is that we're passing in this seed command or this seed argument, I have to say, when we're running the authentication API, and we're doing that because I have to check that. Yes, so over here in the program CS, when you start running this, let me see, here it is. It will look if there's any argument /seed, and if there is, then it will do this seeding, which is, well, pretty useful for us when we're deploying the first time. It seeds everything to the database. And it also does, let me see, it's in the ensure seed data. And let me see where it is. Here, this one. It does a database migration. So as soon as you're starting with this /seed, it also creates your database and migrates to the latest version. And of course, that's really important. And yes, this Alice and Bob, we will get rid of that, but we still want to migrate the database. And if this Alice and Bob are removed, then, well, maybe we will also remove this check and just always upgrade the database to the latest version. But for now, I think this is fine. Just remember, there's always something to improve, and things can always be better. So I'm pretty confident with what we have. So this is all the work we did in the backend. We can run it either as a, doesn't show me here now because I have multiple startup projects, but we can run it as a Kestrel application. Here it is. We can run it here with Kestrel, or we can use Docker to run it. And of course, in production, we're using it on Kubernetes. So thank you for watching, and I'll get back to you soon with a new episode where we're going to look to the front end of the game. Please press the thumbs up button and subscribe to the channel to stay up to date. See you next time.